In our fourth lesson, we'll talk more about conceptual understanding, what it is, how to know if it's the focus, and how you can support your child to build it. Conceptual understanding is all about the why of mathematics. It's about understanding mathematical ideas at both a high level and a deep level. By high level, I mean that students know what something means and they can describe it in simple terms. For example, what is area? What is ratio? What does it mean to solve an equation? By deep, I mean that they understand the underlying structure of the idea. For example, with fractions, they understand when we can add two fractions together immediately and when we need to create equivalent fractions first. They can explain why that's the case and why it doesn't make sense to add two fractions with unlike denominators by simply adding the numerators and the denominators together. Now, you might be wondering why that's important. I mean, do they really need to know why? Isn't it just simpler to teach them the rules and have them practice? I hear you. It does sound easier, and it would be nice if that worked. But the truth is that when we only teach students the rules and procedures, but not why something works or doesn't work, we limit their ability to apply the information in new and different situations. What tends to happen is that students get all the rules mixed up. When I taught middle school, I taught the students how to solve word problems about proportions, but we didn't talk enough about what the proportions really meant and how to know if the situation in the problem was actually proportional. What ended up happening is that in the next unit, which was about finding area, surface area, and volume, they tried to set up a proportion whenever the problem had three numbers and a missing value. They didn't truly understand when to use each of the tools that they had in their math tool belt. So it was as if they grabbed a hammer every time, even when they needed a screwdriver or a wrench. But when students have conceptual understanding, they understand when they can apply procedures to a situation and why they work. This helps them to apply their knowledge in the right way at the right time. And for this reason, conceptual understanding is the foundation of all math learning. Now that you know why conceptual understanding is so important, let's talk about how you'll know if it's the focus of your child's learning. In the progression of math learning, conceptual understanding typically comes first, and we see that in the standards. For example, you'll usually see the words understand, reason, explain, or interpret early on when a new topic is being introduced. Let's take our example of fractions. In third grade, students are introduced to the concept of a fraction. In the standards, we see develop understanding of fractions as numbers as a cluster heading. Here's what this might look like in problems. As students move on to the next grade level, we build on their understanding of fractions. So in fourth grade, we see extend understanding of fraction equivalence and ordering. By fifth grade, we're moving towards fluency with adding and subtracting fractions. Use equivalent fractions as a strategy to add and subtract fractions. Now, one note is that this is not the only work students do with fractions in these grades. There are other standards and clusters that focus on multiplying and dividing, but I just wanted you to see how the study of fractions starts with a focus on understanding what fractions are. Let's look at an example of a different concept that's introduced in middle school, the idea of solving equations and inequalities. In sixth grade, students are formally introduced to the idea of solving equations and inequalities and what that really means. What's the purpose? What are we trying to do? Here's the language from one of the sixth grade standards. Understand solving an equation or inequality as a process of answering a question. Which values from a specified set, if any, make the equation or inequality true? And here's an example of the work students might do to help solidify this idea. Note here that prior to 6th grade, students are thinking algebraically. That is, they are thinking about how to find missing numbers and how to represent them in number sentences, but they might be using a question mark or a shape to represent the unknown number. And they're certainly not, quote, solving equations using the same methods that they'll use in middle school. Now again, as learning continues, students will move toward fluency and problem solving. So we see that reflected in the 7th and 8th grade standards. Let's look at 7th grade. Solve real life and mathematical problems using numerical and algebraic expressions and equations. In 8th grade, analyze and solve linear equations and pairs of simultaneous linear equations. That means systems of equations. Again, this does not represent all of the work students will do with equations in middle school. And truth be told, they do start solving simple equations in 6th grade, and they also problem solve in real-world situations. So I don't want you to get the wrong idea that students spend an entire year simply understanding what an equation is and what it means to solve it. But again, just wanted you to see that we always start with this idea of conceptual understanding and what does this really mean? Okay, at this point, I don't want you to panic. As a parent, it's not your responsibility to know the nuances of every concept or skill your child needs to know in every grade level. So go ahead and let that go. You don't need to memorize or know all of those things that I just talked about in the different grade levels. Remember, what I was just trying to show you was that we're always starting with conceptual understanding at the beginning of a learning progression. And so what's important is that you don't jump straight into procedures and rules or tips and tricks if your child does not have a clear understanding of the big picture first. So applied to this situation, what you don't want to do is teach them all the rules and the steps for solving an equation or adding and subtracting fractions if they aren't sure what the equation represents, why the steps work, or even why they'd want or need to solve an equation. With fractions, you want to make sure they understand what a fraction is, that it represents, that the pieces are equal parts, things like that, before you jump into how do you execute this procedure. All right, so hopefully you're feeling clear about not only why conceptual understanding is one of the 3 types of math learning and how to know when it's the focus of instruction. But you may be wondering, how can you help your child develop conceptual understanding? So next, I'm going to share a few of my favorite strategies for building conceptual understanding. First, discussion and reflection. Think about how often we as adults gain a deeper understanding of something by talking about it with someone else. Students are the same way. One of the best ways to build conceptual understanding is to allow students to do a problem and then discuss it with them. You can ask them to explain what they did and why they did it. You could ask them to tell you why they think their answer is correct. Other ideas might be to ask them how something is similar or different to something else, whether it's the problem they just solved, or 2 numbers, or 2 equations, or 2 diagrams or graphs. In fact, some of the standards state this specifically, like we see in this 4th grade standard. Multiply a whole number of up to 4 digits by a 1-digit whole number, and multiply 2 2-digit numbers using strategies based on place value and the properties of operation. Illustrate and explain the calculation by using equations, rectangular arrays, and/or area models. And a reminder here, I don't expect you to read every standard or have them memorized. However, if you do decide to skim through them, you'll notice this strategy embedded in the learning progression. Frequently, students are asked to explain. A second strategy to support conceptual understanding is the use of manipulatives and visual models. A manipulative is a concrete item that students can use to visualize numbers and concepts. They help students picture what's going on mathematically. For example, in this picture of my daughter, she's moving the counters in pairs as she counts by 2. And that helps her understand what's going on when we're counting by 2s and that concept. Oftentimes, we're tempted to teach students the way we do problems now as adults, or perhaps how we were taught the procedure as a student ourselves. Typically, solving problems using a procedure or an algorithm is the most efficient way. So it makes sense to us as adults to use that strategy. And in turn, we want our kids to use that same strategy. And again, I get it. Why would we do something that takes longer than it needs to? The reason is that going straight to solving problems in the most efficient way is usually the most abstract way. And if we go immediately into the abstract, it's like cutting their learning off at the knees. There is extensive research showing the best way to develop long-term learning and understanding is through a progression of concrete experiences first, think 3D here, then more representational experiences such as drawings or visual models, think 2D here, and finally abstract, think numbers and symbols only. So again, if we skip the earlier stages, even if we have the best intentions possible in order to make it easier for our kids or to save time or to save them from confusion, we're actually undercutting the learning process. A final strategy I'll touch on is the use of multiple representations. And what that means is using different ways to represent the same problem or situation. For example, we could use both a table and a graph to illustrate the idea of linear relationships. By analyzing each of the representations and looking for similarities, students gain a deeper understanding of what it means for a situation to be linear. And remember, this is one of the most important aspects of building a strong foundation of conceptual understanding. So let's do a quick recap about concepts and understanding in math. It entails high-level understanding and deep understanding of math ideas. It's about defining concepts and describing them in simple terms. It's about knowing when a concept or idea is present in a problem. And it's having the ability to explain and justify the steps you took and your solution. Words that indicate a focus on conceptual understanding are understand, reason, explain, and interpret. 3 strategies you can use to support concepts and understanding are discussion and reflection, manipulatives or concrete models and visual models, and multiple representations. Finally, I want to remind you that conceptual understanding is the foundation for success with procedures, fluency, and problem solving. So don't underestimate its value or skip it altogether. And don't forget that I've already identified the most essential concepts to develop in grades K through 8, so that you don't have to go on a scavenger hunt looking for them. They are in the Essential Math Skills and Concepts to Master in K-8 Math resource that's included in this course, so be sure to take a look.